For today's quiz, we're going to be asking you to find the number that precedes this sequence of numbers. 233, 377, 610, 987, and 1597. I'll hold that quiz up right now. It says, can you determine the number that precedes 233 without using addition or subtraction? That's your quiz. Give it a whirl. As always, write down as much as you can and then put your confidence level. Typical student responses are going to be like, wait a second, you're telling me I can't use addition or subtraction? And they're going to ask, how would you ever know? And I'll say, I wouldn't. So you're going to be able to do whatever you would like, but in the explanation, I need you not to use addition or subtraction. And they're going to say, hold on, isn't addition and subtraction kind of related to multiplication and division? I'll say, yeah, that's fine. So I'll give them this hint. I'll simply say, look, 2 plus 2 equals 4. But isn't 2 plus 2 the same thing as taking 2 twice? They'll say, that does sound interesting. And that's all I'll give them. After that, they're going to come up with a variety of answers, a variety of ways of getting this. But again, in their explanation, we do not want them to show that they got this using simple addition or subtraction. That's going to force them to dig a little bit deeper. Some of the students are going to say, look, we got this. And they're going to be able to explain this by saying, first thing we did is we took 1597, and we divided that by our 987. And we put this in our calculator. They're going to end up getting an interesting answer. We turn this on, and I can say 1597 divided by 987. I hit enter, and I get this weird number. That's going to be equal to our 1.618. Students that haven't got this are not going to understand, and they're going to say, well, that's just an odd number. Who cares about that number? They'll say, but watch. If I were to take 987 and divide that by 610 and put that in my calculator, and other students might join in at this point, and they'll say 987 divided by 610, whoa, we get the same exact answer again, 1.618. And when they take our 610 divided by our 377, they put that in their calculator, and again, they get 1.618. And you'll never guess what's going to happen next. They're going to say, well, I'm going to have 377 divided by our 233, and lo and behold, they get that same number again. So now that they have that, and this is some really good thinking, how do you get this next number over here? And some are going to say, well, we had to divide this 233 by some number here, and we get 1.618. The students that are good at algebra will say, well, look, all I have to do is I can set x. I could say, well, 233 divided by my 1.618, and then I could take the x up here like this, and I could end up putting that in, and then they'll say 233 divided by 1.618 equals 144. So they're saying the answer must be 144. And that's an interesting one because they already know this answer. Why? Because they did the addition and subtraction. Of course they did. And then, if they're smart, because they've already taken another one of these quizzes that deals with our Fibonacci series, they're going to say, it's just part of the sequence. They already knew this. In fact, let me just draw this out. We could say our Fibonacci sequence was we had our 0, and then we had our 1, we had our 1, 2, 3, and if you remember, we add the 2 before to get the next number. So 3 plus 2 would end up giving us our 5, and then this 3 and 5 together would give us our 8. 8 and 5 would then give us our 13. That would end up giving us our 21. This next number would be our 34, and then that would be 55. And this is how you end up building the numbers for the sequence. And then we would end up having 89. And then look, 89, which is almost 90, plus 55 would be 145 minus that. So that would be our 144. And then our next number would end up being our 233, and so on. They add. This is just part of the Fibonacci sequence. So our 144 that we got there makes perfect sense. And by the way, all of the students are going to add, and they're going to say, look, I can just do addition and subtraction, and they'll get this. So really, really good thinking. So the answer is 144. But we're going to go into a deeper dive. Let's go for a deeper dive here. Let's just go over what we found. If I wanted to go from 144 to 233 to 377, look, each time I'm going here to here, I'm really multiplying by 1.618. To go from here to here, I'm multiplying by 1.618. I think you get the point. Every time I want to go over here, 618, I'm just multiplying like that. 1.618. All right. Now, that ratio, or that number, it's like a coefficient, is really important. It happens to be so important that we give it its own name and value or variable. This is called the golden ratio, this 1.618. And we give it its own special symbol, phi. And I'll just spell that out, F-H-I. Phi, Greek letter. I happen to make my Greeks in cursive just like everything else. So look, this might not be that bizarre because I could have done this with anything else. I could have had a different sequence. I'll do this one in red. Hopefully this will make sense. Imagine if I did something like, if I had 10, and then 100, and then 1,000. I could do the same exact thing. I could say, well, here, all I'm doing is to get from there to there, I multiply by 10. To get from here to here, I multiply by 10. If I wanted to go the other way, I would simply take the inverse. In other words, I could say, if I wanted to go from 1,000 to 100, I could multiply this way by 0.1, or 1/10. Does that make sense? Multiply by 0.1 again. In other words, I could say 1 all over 10. And I'm going to use, well, I'll do this real quick. I'll do 1 over 10 equals 0.1. They're simply inverses of one another. I can do the same thing here. So instead of going and multiplying by 1.618, I could have gone the other way. I could have went back this way. And what is the inverse of 1.618? I could say 1 all over our phi value is going to be 1 all over 1.618, which is going to give us a value. Let me put that in my calculator. 1.618, and I'll take the inverse of that. I did it wrong. 1 divided by 1.618. Whoa, that's weird. It's 0.618. So is equal to 0.618. That is a bizarre property. You might say, well, why? Why is that bizarre? I'll show you in a second, but let's just show you that if I wanted to go back this way, I could multiply by 0.618. If I wanted to go here to here, I could multiply by 0.618. Here to here, multiply by 0.618, and so on. And then to get my 144, I could have just taken my 233, multiplied that by 0.618. And you might say, that's not that exciting. It is, because of this next step. There's something really bizarre here. If you notice that I've got 1.618 for our phi, and the inverse is 0.618. In other words, I could say that 1 all over phi is equal to phi minus 1. And that is truly bizarre. Think about that. 1 over itself is equal to itself minus 1. Now, I think we can see that. We could see phi, which is 1.618 minus 1, would end up giving us the inverse, which is 0.618. That doesn't happen. Like, look, if I did that over here, let me just show you. Let's try and use this same identity right here and try to use that with our tens. So in other words, we've got this interesting property. Let's try and do that with our values of 10 here. And I have this in red. And to give it a symbol, just like phi has a number, let's use the Roman numeral X for 10 in this case. So I could say 1 all over X, and I'll make it look Roman, would be equal to X minus 1. Does that work? And the answer is clearly no. That would be 1 all over 10 equaling 10 minus 1. 1/10 does not equal 9. So this right here does not work. But it does work for this relationship. And that's what makes it so special. Think about that. You have a number over itself being the same thing as the number minus 1. That doesn't happen any other time. That is truly unique and something that we found with this 1.618 that we found from using the Fibonacci sequence. Let's go one step further and then we'll wrap it up because we already got our answer of 1.44. If I have a little bit of room, maybe right here, look, I can end up taking this one step further and just showing one of these interesting properties. And I just want to point out that this one does work. I actually put the numbers in here to see if this worked. I could say 1 all over 1.618 is equal to 1.618 minus 1. In other words, if I were to put these in the calculator, which I already have here, 1 divided by 6.18, they're both going to end up being our 0.618. And that does work. I'm almost out of room. Let me see if I can squeeze that right here. I'm just going to take this formula here, and I'm going to simply take this phi up here and distribute it through here. So if I came in this direction here, I could say I'd have my 1 left over here, and I would end up saying is equal to our phi, and then I'd have our phi minus 1, which I'll take it over here, and I just want to point this one out. Notice we would have our phi squared minus phi equals 1. And if I took one last step, which I'm really out of space here, I could say I'll leave a 0 here and say our phi squared minus phi minus 1 equals 0. That's bizarre. That is the minimum coefficient you could have for this polynomial. We're going to end there. We'll come back. We'll make that a whole new quiz. All right. That's your quiz for today.